Today we're going to talk about how to add and subtract rational expressions. So the main difference between adding and subtracting versus multiplying and dividing is with adding and subtracting, you have to find a common denominator. So you must have a common denominator. Okay? So with multiplying and dividing, it was a little easier because we could just factor all of the trinomials or any of the quadratic expressions, and then we could cancel things out. When I'm adding and subtracting, I'm not allowed to just cancel things out. I have to find a common denominator first before I can add or subtract the numerator. So let's go ahead and let's practice. Let's find the least common multiple so we can find the least common denominator of the following. So if these examples down below were denominators, I would want to find the least common multiple. So the least common multiple between 4 and 3 is 12. And a lot of times the least common denominator is just the product of the two numbers that you're looking for. And notice 4 times 3 is 12. But 12 is the least common number that 4 and 3 are both a multiple of. What about 2x and 5x squared? So if I look at just my numbers, the common multiple between 2 and 5 is 10. But then the common multiple between x and x squared is x squared. Because x multiples are x squared, x cubed, x to the fourth, x to the fifth. X squared multiples are x squared, x to the fourth, x to the sixth, x to the eighth. So the least common multiple would be x squared. If I go ahead and I look at number 3, notice number 3, one of my options is a quadratic, so I can factor that. That's a difference of squares, so that's going to be x plus 2 and x minus 2. So notice x minus 2 is both used, so that's one number, or one multiple, and then the other factor is the other multiple. So when I'm factoring, basically whatever my factors are would be my least common multiple. So go ahead and try number 4 on your own, and then I'll give you the answer. So I notice the right-hand term, I can factor x plus 4 and x plus 1. So x plus 1 is already a multiple, and then just x plus 4. I'm just multiplying my two numbers together, just like over on number 1, I was multiplying 4 and 3 together. So if we now go ahead and we scroll down and we look at steps for solving, I have steps to make our lives a little easier. You can go ahead and highlight these two if you wanted to. So step 1, factor each denominator. Step 2, find the least common denominator, just like we did above. Step 3, multiply each fraction to have same denominator. Step 4, I'm going to add, or I just say CLT, which stands for combined like terms. That's if I'm adding, so we'll say to add. To subtract, and I'm going to hopefully show you a trick with subtracting because it's a little easy to mess up with subtracting. You want to distribute the negative to second fraction. Last step, factor. Hold on one second. I'm going to factor the numerator and simplify if possible. Sometimes that's not possible. More times that's not possible than is possible. So just keep that in mind. So I'm going to go ahead and let's look at the first example. So if I look at number 1, I know I'm adding because there's a plus sign between them. So in order to add, I have to have common denominators. Notice my denominators are the same, so I can just add at the top. So 7 plus 3 is 10, and 10 over 4x. So my last step is always simplify if you can. 10 over 4x can both be divisible by 2, so I can say 5 over 2x, and I'm done. If I want to do my restrictions, it's the exact same thing with adding, with multiplying and dividing. When is my denominator not allowed to be 0? So x is not allowed to equal 0. Same thing up there and down there. So if I look at number 2, first thing I'm going to do is I'm going to factor. So factors of negative 12 that make 4. That's 6 and negative 2. And notice up here I have the exact same thing. So because my denominators are the same, I really don't have to factor. This is really only if they're not. But I factor just so I can have it and to be safe. So notice that I'm subtracting. I always change that to a plus and I make my second fraction negative so my brain doesn't forget. So if I look at the denominators are the same, so I'm going to have 2x plus negative 4, so in this case it's just minus 4. This trick that I just showed you right here isn't really necessary for this specific problem, but it'll help us be successful when these problems get a little harder. So I can then factor a 2 out of the numerator, and I have x plus 6 and x minus 2. And notice these factors cross out. So I'm left with 2 over x plus 6 is my answer. My domain restrictions, oops, I'm just writing things because I feel like it. But x is not allowed to be negative 6 or 2. That would be 0. And I'm done. Go ahead and try number 3. Why don't we pause this video and you try number 3. So you try number 3 on your own and then unpause it, and I'll put my work on the board. So I'm going to change this to a plus negative 9. My denominators are the same, so I can just say x squared minus 9 equals x minus 3. So now I can factor the top as a difference of squares. And I see x minus 3's cancel out, so my answer is just x plus 3. So my domain restrictions are just negative 3. Okay. Number 4 is where it gets a little bit more fun. So notice I have to factor the denominator. I'm actually going to erase this and scroll if that's okay. Number 4, I have to factor the denominator. So that's going to be x minus 3 and x plus 1. So notice my common denominator is x minus 3 and x plus 1. So now I'm going to ask myself, if I look at the left fraction, is there anything that the denominator of the left fraction doesn't have? It has both x minus 3 and x plus 1, so I don't have to multiply anything to 4x, it just stays 4x. If I look at my right fraction, is there anything I need to multiply to that to have the common denominator? Well, this fraction only has a denominator of x minus 3, so that means I have to multiply this fraction by x plus 1 on the top and the bottom. Now, I don't really need to worry about the bottom because I already wrote it down here. So I just have to look at the top and I just have to double distribute. So x times x is x squared, and x times 1 is x, and negative 1 times x is negative x, and negative 1 times negative 1 is negative 1. So now I can go ahead and clean all of that up. So I have these cancel out. So I have x squared plus 4x minus 1 all over the denominator. So I'm just combining like terms. So if I take a look, if I were to try to factor the numerator, are there any factors of negative 1 that make 4? No. So I'm done. Now if I do my domain restrictions, x is not allowed to be 3 or negative 1. I'll go ahead and I do the same thing with number 5. I see number 5, I have to multiply and subtracting, so I'm just going to make that a plus negative 3 to make my life easier. So if I factor this guy on the left, factors of negative 8 are negative 4 and positive 2. And if I factor the guy on the right, I have x plus 2 and x plus 2. So my common denominator is I have two x plus 2's over here. So I'm going to have x plus 2 times x plus 2, and I'm not going to write that out nicely until the end. And then I have x minus 4. So if I look at my left fraction, decides to write today, what does that left fraction not have in my new denominator? Well, it has an x plus 2 and it has an x minus 4. It's missing another x plus 2. So I'm going to multiply that left side by x plus 2. So I'm going to have to double distribute. So x squared plus x plus 2x plus 2. And if I look on my right fraction, what does that denominator not have? Well, it has 2 of the x plus 2's, but it doesn't have the x minus 4. So this is just saying negative 3 times x minus 4. So that's negative 3x plus 12. If I didn't distribute that negative up into the front of my fraction, I would have accidentally made that negative 12. So it makes your life a lot nicer just to do plus negative 3. It saves you a lot of time, and it saves you from making a silly mistake. So if I combine my terms, I have x squared, and then 3x minus 3x, so those cancel out, and 2 plus 12 is 14, all over x plus 2 squared, x minus 4. I know I could write it like this because x squared plus 14, I knew I'm not allowed to factor, because the only time I can factor when I have two terms is when I have a subtraction sign and they're perfect squares. But now I'm looking at my answer key. Oh wait, hold on. This is number 5. Yep, looks good. So my domain restrictions would be negative 2 and 4. So let's go ahead and flip your paper. And let's do one more together. So if I do this one, I look at 7 over 9x squared and x over 3x squared. So I can't factor the left fraction, but I can take a 3x out of the right fraction. So I'm left with x plus 1. So this one's a little annoying because there's not much of a common denominator. But this has a 3x and that has a 9x squared. So the common multiple is just 9x squared. And then x plus 1. Again, if you wanted to multiply 9 plus 3 and say 27, you're going to get the same number, the same answer at the end of the day. Your problem's just going to take you a little longer to solve. But the least common multiple between 9 and 3 is 3. The least common multiple between x squared and x is x squared. And then I just have x plus 1, so I have to write that as well. So if I look on my left fraction, what part of the denominator does that one not have? It doesn't have x plus 1. So I'm going to do 7 times x plus 1, so that's just 7x plus 7. And I'm going to do the right fraction, if it will decide to write for me today. Come on. There we go. What does that side not have? Well, it already has 3x, but how do I get to 9x squared? Well, that would just mean I have to multiply by 3x. So that's just going to be 3x squared. So now, if I combine my terms, that's going to be 3x squared plus 7x plus 7 all over 9x squared times x plus 1. Here's where you now want to try to factor the numerator. So there's no, I do 21 and 7. There are 7 and 3, 21 and 1. There's no factors, so I'm done. So my domain restrictions. So my domain restrictions would be 0 and negative 1. So I want you to go ahead and try finishing this page. And we are going to save, you can try this side if you would like, this bottom half. Otherwise, next class, I will go over that page, that half as well.